like that. The same thing in chapter 4, we're going to do that, but in terms of two random variables, a pair of random variables. Okay, as you can see on the screen here, we're going to begin with joint CDFs. Okay, so the joint CDF, as you can see here, is given in this expression right here, which is the joint CDF of the joint. This is the joint CDF, which is the probability, the joint probability of two events, A and B. So where A is A is x less or equal to small x, value of x, or B, this is the random variable, or this is the B event where y is less or equal to the value of y. Okay, and this probability represents the intersection between the two events. So basically, the joint CDF is the intersection between this event, okay, x less than small x, or the value of x, and the other event, y less or equal to the value of y. Okay, so that's basically what the joint CDF is all about. Okay, again, as with the single random variable, when we talked about properties of a single random variable, the joint CDF also has some properties, and they are very similar to that. If you go back, let's say, I think I have this lecture. If you go back to lecture 8, I believe, and go back to the properties, as if you remember, we talked about when x approaches minus infinity, it's going to be equal to 0, or goes to infinity will be 1, and fx between 0 and 1. So we talked about this. So very similar. If we for the joint probability, we have the same thing. So the joint CDF for a random variable x and y, it's between 0 and 1, similar to the single one here. Okay, nothing changed. Okay, and also the second one right here is the joint CDF, where one of them goes to infinity, one of them goes to minus infinity, either x or y, or both of them goes to minus infinity. Then the CDF, in this case, the joint CDF will be equal to 0. Okay, and then if both of them goes to infinity, if both of them go to infinity, x and y, both random variables would go to infinity. Then the CDF, the joint CDF, in this case, will be equal to 1. Okay, and then the joint CDF of x and y, where x goes to infinity, it's equal to the CDF of y, which is, we're going to refer to this one as the marginal CDF, which is like the single CDF for y. Similarly, when y goes to infinity, the joint PDF, the joint CDF will be reduced to the marginal CDF of x. Okay, we're going to talk about this some more in a minute. Okay, and also another thing, the joint CDF of x and y is a non-decreasing function of both x and y. So both of them, they will increase; they do not decrease at all. Okay, and then the last one right here is the joint probability of x and y, where x between x1 and x2, the values x1 and x2, and y, the random variable y, between larger than the value of y1 and y2, less than y2. This can be written in this form, which is the joint PDF of x2, y2, plus the joint PDF, the joint CDF x2, y2, plus the joint CDF x1, y1. Then we subtract the joint CDF of x1, y2 minus the joint CDF of x2, y2. So, and all of this will be larger or equal to 0. Okay, cannot be less than 0. Okay. Now, as with the single random variable, if you were given a function and you want to verify this function is a valid CDF or not, the same thing, we can verify a given function is valid joint CDF for two random variables by using these three properties. The first property right here, number 2, number 3, and number 6. So we're gonna make sure that when one of the random variables goes to minus infinity, then the joint CDF, the whole joint CDF will go to zero, and then when both of them will go to 1, will go to infinity, then will be equal to 1. The joint CDF will be equal to 1. We want to verify that, and also we want to make sure the joint CDF is non-decreasing function. So if we can prove that, then the function is a valid CDF. Okay, like we just said here, we said in property 4 and 5, we talked about the marginal CDF. Let's prove that. Let's see if this is really valid. So if we assume that we have two events, A and B, where A is the random variable X less or equal to value X, and B is equal to the random variable Y, where Y is less or equal to the value of specific value of Y. Okay, so obviously, as we just mentioned there, the joint CDF would be equal to the intersection between the two events A and B. Okay, now if we assume that if Y goes to infinity, is not really equal to infinity, goes to infinity, which is right here. Okay, so right here, Y, which is in this case Y is B. So the intersection between A and B, okay, but when the event B, when Y goes to infinity, the event B is actually it's the certain event, okay, which is the sample space. If you recall back in chapter 2, I believe we talked about that. The sample space is the universal set. Okay, so the universal set, it means it's the event less or equal to infinity. It's, everything is less or equal to infinity. So in this case, B is equal to S, which is the universal set, okay, or the sample space. Obviously, the intersection between A and the universal set will have to be equal to A, okay, because A now in this case is a subset of S, okay. So therefore, when you plug in A intersection of S, okay, will have to be equal to the probability of A, and therefore we will end up with the marginal CDF of X. And we can do the same thing, where we can assume X goes to infinity. Okay, so that's how that's how we came up with that one of them, when one of them goes to infinity, then we would end up with the marginal CDF for the other. Okay, quickly, we have a very simple example here. Example on page 3. And let's say we have this CDF uniformly distributed over X and Y, where X between 0 and 1, and Y similarly between X and Y. And the joint CDF, as you can see here, it's given here on the screen. Okay. Now, if we need to find the marginal CDF of X, it means we need to set Y to infinity. We set Y to infinity, which means that we will end up with, we're gonna delete everything related to Y. Okay, so basically what we're saying, like the first one is 0. So where X is less than 0, this one will go away. And this one, obviously, X between 0 and 1, we take this one away, we take this one away. And obviously this, we already talked about it. And this is the last one. So this is basically the marginal CDF. And we can do the same thing to find the marginal CDF for Y. Okay. So now the joint CDF for two discrete random variables. Okay. If we can go back to chapter 2 or 3, chapter 2 basically, and we talked about the joint CDF, or we talked about the CDF for discrete random variable was similar to this one right here. Okay. Now this here, since we have two random variables, so we have two double sum here, where we have two events, m, where we have x has n possible value, n values, and the other one is m, as in Muhammad. Okay, then we can write them the same way. Okay, now this is obviously, this one here is the joint PMF. Okay, the probability mass function, and this is the unit step function. So this is the unit step function for x, and this is the unit step function for y. Okay, so this is basically for discrete random variable. Okay, and obviously if one of them goes to infinity, okay, for example, if y, this one goes to infinity, then this will go to 1, and we'll end up with the marginal CDF. Okay. So this is the end of lecture. This is the end of the first lecture, lecture 16. So in lecture 17, we're going to cover the joint PDF. Okay. And it's very similar to what we did in chapter 2. If you remember in chapter 2, when we have the CDF, we just take the first derivative of the PDF. Okay, if we have the CDF of X, for example, we just take the first derivative of the CDF with respect to X, and we'll end up with the PDF. Okay, similarly here, the joint PDF can be derived from the joint CDF, as shown here on the screen, as you can see it. Okay, the only difference is the joint PDF, how we're going to derive it from the joint CDF. We will do second partial derivative. This is partial. This is not normal derivative. This is partial derivative. What does that mean, partial derivative or second partial derivative? In this case, you will derive or you take the first derivative with respect to X, for example, and then after that with respect to Y. So this is what we mean by partial derivative. Obviously, you already know that. You've seen that in math lectures or math courses in the past. But just to remind you, so you take the first derivative with respect to X, and the result, you will take the second derivative, then you derive again with respect to Y. Okay, so that's how we find the joint PDF from the joint CDF. Okay, and similarly for discrete random variable, if we go back to what we just talked about last thing, which is this equation right here, or this expression, if we take the second partial derivative for this one, we will end up with this equation right here. Okay, because you know, the derivative of the unit step function will give us the impulse function, as we learned in the past. Okay, very straightforward, nothing new to us here. Okay, and again, we have properties for the joint density function as we had for the single PDF for random variable. Okay, and as you can see here quickly, the properties, the joint PDF will have to be equal or larger or equal to 0, cannot be negative, and also the joint PDF, the area under the joint PDF will have to be equal to 1. And if we need to find the joint CDF from the joint PDF, you use this expression right here, where you have to do integration twice, of course, from -infinity to X and -infinity to Y. And to find the joint CDF, for X, for example, to find the marginal CDF from the joint PDF, you will set, for example, you will set one of them to infinity. So it's going to be minus infinity to infinity. For example, this one here, X, you will set this one to infinity, and then the same thing for Y, you set it to infinity. We'll talk about this one in a minute. So we learn how to find the CDF, the marginal CDF from the CDF itself. Now we're going to find it from the PDF, okay? And similarly, the joint PDF, the joint probability of X and Y, where X between X1 and X2, we can get it from, we learn how to do it from the CDF. Also, we can do it from the joint PDF as well by take the integration, double integration, where the limits X1 to X2 and Y1 to 1, 2, okay? You know, if you go back to chapter 2, they are very similar, okay? The only thing, we just add an integration for the other random variable, okay? And also the marginal PDF. So we can also derive the marginal PDFs from the CDF, the marginal PDFs, okay, from the joint PDF by, for example, if we need to find the marginal PDF for X, okay, we will integrate with respect to Y, okay, and then if it's Y, we'll integrate with respect to X, okay. And also, again, if we need to verify whether a function, a given function, is valid joint PDF or not, we want to make sure it's positive, larger or equal to 0, and the area under it is equal to 1. So these are two properties that can be used to determine whether the function is valid PDF or not. Okay, on page 2, this is just to show you, if you go back to page 1 here, property number 6, this is how we find the marginal PDF. This is on the second page, this is a proof how we came up with these expressions for marginal PDFs. So basically, so the fx, or the marginal x, is equal to the first derivative of the first derivative of x. Okay, so if we plug in fx right here, fx, we go back here to expression 4, or equation 4 right here, and plug it back in here, and you do the integration. Now keep in mind the derivative, or the first derivative of the integral of d of x, where the limits from minus infinity to x is equal to 1. Of course, you can do that yourself. Okay, just do the integration, and you have two limits from minus infinity to x is going to be equal to 1. So here outside is equal to 1. Okay, then we will end up with the one inside. Okay, and that's how we ended up with this equation 6, the first part of equation 6, which is the marginal CDF, the marginal PDF for X. And similarly, we have the marginal PDF of Y. So, of course, this is just to show you how we got it, of course, but the main thing you need to focus on these two equations, how you find the PDF and the CDF. And also, if you go back here, like I said, we can find also the CDF. So let's take a simple example. Let's go back to the example we had last lecture, just a minute ago, where we are given the joint CDF, okay, which is the uniformly distributed over 0 and y, where x and y between 0 and 1 each, okay, And so we have the joint CDF, and we need to find the joint PDF. So how we do that? Like I said at the beginning of this part of the lecture 17, we said we take the second partial derivative. So we take the first derivative with respect to y, with respect to x. So if we do that, so this one going to be 0, this is going to be 1, this is going to be 0, this is going to be x, and this is going to be 0, of course. And now if we do it with respect to y, again, so it's going to be 0, and this one we said it's 1, so it's going to be 0, and this is 0, and x, the derivative of x is going to be 1. This is the first derivative of x and y is going to be y. So when we take the second derivative, or the second time with respect to y, is going to be 1. So this is the end result. Okay. So this is the joint PDF for this CDF. Very straightforward. Let's take another example here. This is very similar to the examples we had back in chapter 2, where we had the PDF and we need to show, say, a constant, given a constant and within the function, we need to find that value for that constant. So here, suppose we have b is a positive constant in a function g of x, where g of x is given in equation 8 here in front of you, okay? Where x is between 0 and 2, and y between 0 and pi over 2, as you can see here on the screen, and 0 otherwise. Okay, thank you. So we need to find b, which is the constant b, so that this function is a valid PDF or joint PDF. So we want to make sure this function is a valid PDF. So depending on the value b is variable, so we need to find it, okay, to make sure this function is a valid joint PDF. And if we go back to the beginning of the lecture, we said, you know, to make sure, first of all, we need to make sure that this function is positive, it's not negative. And then we need to find the area underneath it. It's equal, will have to be equal to 1. So obviously, if you look at the values of x and y here, so the value of x is between 0 and 2. So any value, if you plug in x here, if you plug in any value between 0 and 2, or any value for y between 0 and pi over 2, this will stay positive. Okay, of course, it's not going to go to negative. So, which means this property is satisfied. It means this is it's always this function is larger or equal to 0. So it can be 0 because cosine of pi over 2 will be 0. So the whole thing will be 0. Okay. Now the second part that we need to satisfy is part 2 right here. So we're going to integrate for y and x, right? So we have this function, okay, and we're going to integrate 2 limits. The first limit is for y 0 to 2 pi, and the other one is from 0 to 2. Okay. So we plug in the limits and do the integration, very straightforward. We all know how to do this. And after you end up with, after you do the integration, very simple integration, okay, you will end up with equation 9, right? So obviously the question is asking to find the value of b, and which means that for the function, for the g function here to be valid PDF, b will have to be equal to 1 divided by 1 minus the exponential minus 2, which came from equation 9. Okay, very simple. And as I said, you know, if you understand chapter 2 and also chapter 3, because chapter 3 will be very similar to chapter 5, you know, the operations of random variables, okay? So now we learn how to validate a PDF or joint PDF or find the constant. Now, another example on page 4 right here, we are given a joint PDF, okay, as shown in equation 11 here, where it's x times the exponential minus x times u plus 2 times the 2-unit step u of x and u of y. Okay, and we need to find the marginal PDF for x and y. So let's begin with x, and if we go back to the first page of this part of the lecture to find the marginal PDF for x, okay, you will integrate with respect to y, okay, and of course, since we have a unit step, so you plug in this expression, the joint PDF here, but since we have the unit step of y, so it's going to be from 0 to infinity. There's no need to integrate from minus infinity to 0 because it's going to be 0 according to this, right? So after you plug in the numbers, this is very simple. You just take anything related to x out. Okay, so you will end up with this simple integration, and you do the integration, and you will end up with this equation, equation 12.5, which is the exponential of minus x times the unit step of x. So this is the this is the marginal CDF. So if somebody will ask you find the marginal CDF for x, you do this. So given that a joint PDF is in front of you. Very similar to find the joint PDF of y. Okay, the joint PDF of y, you do the same thing. You plug in the joint PDF. Now we need to find the marginal. Sorry, we need to find the marginal of y, marginal PDF of y. So you plug in the joint PDF and we integrate with respect to x, dx here. Now, now we have unit step x. So y will be out, okay? Now in here, g here, where it's labeled g, we will have to do integration by parts, unless if you have table of integrals. خلينا نقول كنت بالبيت و you have a book for table of integrals, they can do that, but we don't have that. So then we would use the integration by parts like we did in the past. And I'm showing you here, but you should be able to do it yourself. Okay, this is just practice for you. So after you do the integration by parts, you will end up with equation 14. Okay, so this is g. So you plug in so that the joint PDF, the marginal PDF for y will be the unit step of y divided by y plus 1x squared. Okay. And this is the end of lecture 17. So this is lecture 16 and 17. This is what we had last week, okay? So I thought we go through it in case if somebody has any question. Do you guys have any questions so far about PDFs, joint PDFs or CDFs?
دكتور أنا ما عندي سؤال على المادة إذا ممكن.
تفضل.
على الامتحان إنه كان في سؤال لطالب الفاريانس.
اوكي.
الجواب ما كان يعني يطلع معنا، الاشتقاق كان فيه مشكلة معنا.
Don't worry about it. في واحد ودى لي اياه وانا بطلع عليه، وديت له ايميل والطالب اللي وداه حكيت له انه عم قلنا ريفيو، انا هسه مشغول شوي في عندي امتحانات كثير. اذا في مشكله بتطلع اي واحد ما اخذش فول كريدت على السؤال باخذ، يعني مثلا السؤال عليه 2.5، اذا مثلا اخترت انت الجواب والسيستم اعطاك 2.5 خلاص هاي 2.5، بس اذا ما اعطاك بعطيك 2.5.
مشكور دكتور.
العفو ان شاء الله. بتعرف أنا صراحة بدي أكون معكم صريح، أنا ما بحب الامتحانات هاي لأنه بتغلبها، بدك تدخل على السيستم مرات بكون لما تعمل يعني لأن في تشويسز، ما إحنا بنحط 4 or 5 تشويسز مرات، فلما تعمل وبنعمل تايبنج يعني مش إنه مثل ما تقول بطريقة، في طرق ممكن أنا ما بعرفهاش، ممكن تكون طرق أسهل يعني، بس لأنه كل موضوع الامتحانات أونلاين جديدة علينا، فدائما الواحد ممكن انه يغلط برقم او كذا، بس دائما ان شاء الله حق الطالب محفوظ، لانه اذا كان الغلط من عندي انا ما بصير الطالب يتحمله، فان شاء الله بنعطيكم حقه زياده بعونه تعالى.
ان شاء الله دكتور، مشكور.
ان شاء الله. هلا مثل ما حكينا هذول 2 lectures غطيناهم الاسبوع الماضي، كان حاب اني اغطي lecture 18 اللي هو يعني بيحكي عن continuation chapter 4، بس خليه إن شاء الله ليوم الثلاثاء بنغطي نهاية chapter 4 وبنبدأ بchapter 5، لأن إحنا شوي behind، يعني بنكمل chapter 4 اللي هو ضل lecture 18 وبنبدأ بchapter 5. أوكي، أنا كنت بدي أبدأ اليوم بس خلص بكفي اليوم، بجوز تعبنا شوية، فبنكمل إن شاء الله يوم الثلاثاء. Do you guys have any questions in general بالنسبة للمادة اللي حكيناها so far؟
أوكي. دكتور يعطيك العافية.
تفضل.
دكتور هلا إحنا رح ناخذ كمان كويزات لقدام قبل الفاينل؟
طبعا في عندنا كويز، إحنا أخذنا كويز وأخذنا الميد تيرم، وفي عندنا كويز ثاني عليه إن شاء الله 10 علامات مثل سيميلر للكويز الأول. فالكويز الثاني راح يغطي بعرف ايش راح يغطي، ممكن يغطي مثلا يعني بعد ما غطيناش شيء، ممكن يغطي chapter 4 and 5، لانه احنا بالاول شو غطينا 2 and 3 صح ولا لا، اللي هو غطينا البي دي اف سي دي اف وغطينا الاوبريشنز، فممكن نعمل نفس الشيء هون ما بعرف. اوكي، فهذا الحكي راح يكون hopefully within the next few weeks, couple weeks، يعني ما تضلش وقت اصلا، احنا we only have I think 1 month left. اوكي، ف within the next 2 weeks بنحكي معكم ان شاء الله، بكون كويز مثل الكويز الاول بسيط يعني، وبكون هاي نهايه الكويزز، وبضل عندنا الفاينل. طبعا الفاينل ما بنعرف راح يكون بالجامعه اون كامبس ولا اونلاين، لحد الان في ناس بيقولوا هيك في ناس بيقولوا هيك، فمثلنا مثلكم نسمع ان شاء الله and we'll have to wait. Any other questions? Okay, يعطيك العافية. Any other questions شباب صبايا؟ Okay, if you don't have any questions إن شاء الله we'll talk to you on Tuesday. يعطيكم ألف عافية.
يعطيك العافية دكتور.